Hello, everybody. I'm sharing a case study with you today about one of our wedge wire stainless steel cylinders used in the CIL circuit that after supplying it for 10 years, it just started corroding very aggressively. And this led to subsequent premature failures of our wedge wires, stainless steel wedge wire cylinder. Customer called us. We checked on the inside our factory, what has changed, any material or any QC procedures. We couldn't find anything. What we then did was we got a sample from this customer on site, sent to us, and to try and figure out what has happened. I mean, we've supplied this for 10 years and all of a sudden the stuff was just corroding, as you can see on the picture on top. That is not the case of our wedge wire cylinders when they are in operation. You get normal wear, and this is like termed as abnormal wear. So the sample was then transported to our factory in Johannesburg. The first thing we did was we analyzed the material using XRF, and it was confirmed that what we supplied was indeed 304 stainless steel. We then made use of some scanning techniques using SEM and EDS to check on the corroded wedge wire strand if there's any identification of what could have caused this, let's call it excessive corrosion of stainless steel. And it was actually concluded that the presence of chlorides indicated that this is actually chloride-induced pitting corrosion, which we've never seen before in any of our other applications. But I must also say that this customer uses seawater as his process solution in the CIL circuit. And because we could find traces of chloride in the wedge wire strands, it's also clear that this particular client uses seawater as his process solution in the CIL circuit. What we further found is stainless steels are graded with regards to their pitting resistance on a PREN, which is a pitting resistance equivalent number, which I'll come to about in the next slide or two. It uses the components that the stainless steel consists of, and there is actually a formula to calculate that number, and that number tells you how resistant a particular stainless steel is to chloride-induced pitting corrosion. Now, on the graph, as you can see in the middle below the screen, we couldn't understand why all of a sudden now we've been supplying the same cylinder, same material of construction for the past 10 years, and all of a sudden this aggressive pitting corrosion has started. What we concluded or assumed could be the case is that the solution was operating in this region over here. And just as the chloride content reached a certain threshold, there was an exponential increase in the pitting potential. Further tests are still ongoing, but that is what we are trying to conclude with further tests. What we further did was we used the PREN to actually calculate all the different types of stainless steel we can supply in order to solve this problem, obviously, in wedge wire. As you can see, 304 being the least resistance to pitting as per the PREN. 316 follows that. We have 317L. We also have a material called HSP, which HSP stands for hard surface profile. And then we've got the elaborate SAF 2205, which some of you may be familiar with. It was interesting to see that the HSP was actually more resistant to pitting than 316, but when we installed the unit on site, after 3 days of operation, it started pitting, which just went against what we tried to achieve. But it must also be noted that your PREN should not be the only consideration to determine the pitting potential of a particular stainless steel. Again, HSP, molybdenum content 0.3, 316, molybdenum content 2.1. But the manganese content was very interesting for us. We thought that because of it, you know, in mining applications, manganese is work hardens, so the material would become hard after working for a while. But be that the case, I mean, we tried to actually reduce corrosion in this instance, and yeah, not so much wear. What was really interesting was we received some feedback about a few weeks ago that 316 was actually the go-to material in this application. So what we are trying to achieve, or the message we are trying to share with you today, is if you have a material in a given solution that is failing as a result of corrosion, be it galvanic, be it pitting, or stress corrosion cracking, there are ways and means to determine why and how. And there's also other alternatives to address your problem should you have it on your site. Thank you.